Hi, welcome back. This is the home edition of the lecture video game. We're going to be taking a moment to look at the radius and diameter formulas. That's going to help carry you through this assignment 10-1, circles and circumference. But before we get there, let's go ahead and give you those formulas and show you how they get used. So going into our notebook here, I'm flipping to the very end of the circle vocabulary section, which was right here. So that was the previous video. I'll put a link on screen to both parts 1 and part 2 of those. But let's go ahead and kick it off with some radius and diameter. Just setting up my notes here. This isn't going to take very much space in our notes, so we'll devote just one page, I think, to this one. Zoom in here. Whoa! That's what the world looks like before I find my glasses. Okay, from the previous section, we had the definition of both radius and diameter. The radius was a segment where the endpoints are on the circle and in the center of the circle. And when we're talking about more than one of those, we use the plural of that word, which is radii. And then the diameter is this chord, a segment where the endpoints are on the circle. But this chord is special in that it goes through the very center of our circle. So we're going to be looking at the relationship between those two items right now. So we've got two formulas to give you. We have the radius formula. When we look at the radius in terms of the diameter of the circle. So if we have one radius, it'll be equal to the length of the diameter. Again, we're going to be using d. I know so far this course we've been using d for distance, but right now, since we're talking circles, d is going to represent the diameter. So you can either divide the diameter by 2 or multiply the diameter by 1/2. And these both are going to accomplish the same task. So there's our radius formula. And here up next is going to be our diameter formula, again given to us as in case as if we were given the radius. So one diameter is going to be the same as multiplying the radius by 2 or by adding the radius to itself 2 times. Both of these accomplish, again, the same goal. So let's go ahead and do some examples. This example will walk you through some of the tasks that you need to do on lesson 10-1. I will be cutting a full walkthrough video for that. Let's assume we have a circle, and in this circle we have some sort of segment named QV, and its measurement is 8 inches. Using just that information, we would like to know what the measure of the diameter of circle Q is. All right, so let me zoom in a little tighter on this example here for you so it's easier to see. I need to draw a circle. I'm going to freehand the circle here because I don't have a handy dandy compass. And since this is just notes, we can sketch. Here's the center. We're going to call the center of the circle. We're going to name it Q. Looks like we've got a segment that goes Q to V. So some point on the circle will be named V. Looks like this thing is a radius because it fits the definition that we looked at earlier for a radius, meaning that it goes from the center of the circle, in this case is Q, to some point outside the circle, or excuse me, some point on the circle, which we're calling V. We want to know the diameter for Q. The diameter of circle Q is any chord, which means endpoints are going to be on the circle. And this chord is special in that it has to go through the very center of the circle. I clearly put those points in the wrong spot, so we're just going to adjust them a little bit so that they fit. Okay, there you go. So that would be one of our diameters. Let's go ahead and give it a quick name. We don't have to. I guess I'll just leave it without names for now. But this chord, the distance of this chord is what we're looking at. Since we're being asked for diameter, using the diameter formula would be the best choice here. So D equals 2 times R, where R is representing the radius. In this case, I was given that the radius was 8 inches. And so the diameter of this circle is 2 times 8, or 16 inches. That is the simplest way I could make this, but what if I were going to try to make this more complicated? No big deal. Let's ask the same question, but instead of giving it to us in a number, QV is 8 inches, let's see what happens if QV were some sort of equation, some sort of expression rather. Let's say 2x minus 1. And let's say this diameter is, oh, I don't know, 15. Now the question becomes, what is the value of x? Same sort of thing. Notice that QV, again referring to this circle here, QV is some sort of radius, and we're given information on the diameter. So we're going to start with the exact same formula. I'll show it to you using radius formula next. But using the exact same formula, I'm going to fill in what I know. The diameter is 15, and that is the same as 2 times the radius, but this time the radius isn't a number, it's this algebra expression right here. Okay, I have no idea what's going to happen. I just made stuff up off the top of my head. I'm going to go ahead and simplify this right-hand side by doing the multiplication that I see here with the parentheses. So 2 times 2 is 4. 2 times negative 1 is negative 2. And now I'm going to go ahead and solve this equation for x. I'm going to remove this subtraction by 2 by adding 2 to both sides. That's going to give me 4x on the right, and 15 plus 2 is 17. Divide both sides by 4, and I'm going to be left with, oh goodness, I don't know off the top of my head. Going to my favorite calculator app here. I know it's not showing on screen for you, but trust that I had a calculator handy off screen. And there we go. Whoops. Helps if I scroll it up a little bit. There you go. So in this case, x was 4.2. Now I had mentioned being able to do the same thing with one of our radius formulas, so I'm going to go ahead and show you that. The radius equals 1/2 d. You could also use this with d divided by 2. I guess let me show you that one. I happen to like the written version of this one better. So diameter divided by 2. So again, going to replace what I know. Here's the radius and my diameter. Now I want to get rid of this fraction. I can multiply both sides by 2. The moment that I multiply both sides by 2 to get rid of this division by 2, I end up right back here on this line from the diameter formula, and I can continue solving for x. If you're okay with having a decimal right here, you could have just done this division. 15 divided by 2 is, I think like 7.5, and then run it. You should end up with the same answer. But there you go. That's how you would use the diameter and radius formulas to do some calculations.